Dear students, welcome to all. Today we are going to study one of the most important power amplifier circuit in analog electronics, namely the transformer coupled class A power amplifier. So please observe the circuit carefully. At first glance, it may look complicated, but once we understand the function of each component, the circuit becomes very simple. First, we discuss a question: can a small transistor directly drive a loudspeaker? Yes or no? Definitely, it is no. A loudspeaker usually has a low impedance, 4 ohm, 8 ohm, or 16 ohm, whereas the transistor has a much higher output impedance. So, if connected directly, very little power reaches the speaker, efficiency becomes poor, much power is wasted as a heat. To solve this problem, we use a transformer between the transistor and the loudspeaker. Hence the name transformer coupled class A power amplifier. First input signal. This is a weak AC signal coming from microphone, mobile phone, audio player, previous amplifier stage. So this signal is too weak to drive the loudspeaker. So input coupling capacitor, which is called C-in. Why do we use a capacitor here? Remember, a capacitor blocks DC, allows AC. Therefore, C-in allows only the input audio signal to reach the transistor while preventing any DC voltage from the source. Biasing resistors R1 and R2. So these two resistors from a voltage divider bias network, their work is to provide proper bias voltage, keep the transistor operating in a active region, stable the operating point, that means Q point. So without proper bias, the transistor may enter cutoff or saturation and the amplifier will not work properly. So next transistor is connected. This is part of the amplifier. A small variation in base current controls a much larger collector current. Hence, small signal becomes large signal since this is class A operation. The transistor conducts throughout 360 degree of the input signal. That means the transistor never turns off. So emitter resistor RE. Now observe the emitter resistor. What is the purpose? So its main function are thermal stability, bias stabilization, prevents thermal runaway. As temperature increases, collector current also increases. Emitter resistor develop more voltage, which automatically reduces base emitter voltage. Hence, the transistor becomes stable. So next, bypass capacitor CE. Notice that CE is connected parallel to RE. Students already know that RE provides stability, but unfortunately RE also reduces AC gain. So therefore CE bypass the AC signal around RE. So while RE still stabilizes the DC operating point, hence we get good stability and high gain simultaneously. So next, the transformer. As now come the important component. The transformer replaces the collector resistor. It has primary windings N1, secondary winding N2. The primary is connected in the collector current while the secondary is connected to the loudspeaker. So why the transformer? So this is a favorite examination question. The transformer performs impedance matching, then DC isolation, then voltage transformation, then finally a loudspeaker. The amplified AC signal reaches the loudspeaker. The loudspeaker converts electrical energy into sound energy. So this is the final output. So next, coming to the working principle. So now let us understand the complete operation step by step. A small AC audio signal is applied through C-in to the transistor base. R1, R2 provides the required DC bias. The transistor operates continuously in the active region. So next, the transistor amplifies the collector current Even a very small input signal produces a large change in collector current. The varying collector current goes through the primary winding. This creates a changing magnetic field. According to Faraday's law of electromagnetic induction, this changes magnetic field introduce an AC voltage in the secondary winding. The amplified AC voltage and current appears across the loudspeaker. The loudspeaker converts electrical energy into sound. Thus, the weak input audio signal becomes a loud sound. So why it is called class A? Because the transistor conducts during the complete 360 degree of the input signal. The efficiency is around 25 to 30%. So about 50% the transformer coupling. The main advantages of this transformer coupling is maximum power transfer, better impedance matching, no DC reaches the loudspeaker, high efficiency than RC coupled class A amplifier, suitable for audio output stages. So the disadvantages are transformer is bulky, more expensive than RC coupling, frequency response is not perfectly flat, transformer introduces some distortion at very low and very high frequencies, magnetic losses reduces performance.